So hello and welcome back. We are going to have now a time to review for the test. I don't know if you noticed my message on the chat box here. If you go to our Canvas course page and you locate the module where the study guide is for the exam, there's a section there about the exam 2 materials. You should be able to find in there the PowerPoint that I'm about to show. So if you want to follow along, that's fine. There are several exercises at the end of it. And if you actually download the file to see the actual slides, the answers are written in the bottom for, I think, the majority of them. So what I'll do is I'm going to go quickly through it. I just want to highlight what are the things that you should have a good understanding of, all right? And then we will leave it open for just discussion if you guys want, and we can talk about, if you want, we can solve some of the problems now. Technically our session would end at 7, but I left some time in there in case you guys want to stick around and work on some of the problems with me here. We'll set a time for that though, okay? Because I am going to have to take care of some things here when we cut off, all right? So as I was saying, uh, if we go to our course page here in Canvas, right, you should be able to find in the modules section. And again, you know what? Actually, let me do this. Let me show you the student view here, just so it doesn't look like it's mine. So again, if you go here to the modules section, this is where you typically download all kinds of things. So over here, you have the exam 2 materials. See that link there, exam 2 review. If you open that, here is the PowerPoint that I'm about to work with. Okay, so you can download it or you can view it. I would download it so that you can see the answers on each slide, which you cannot see during the slideshow itself. All right. So with that in mind, let's go ahead and work this out. Let's go ahead and do our exam 2 review. Yeah. Okay. So this exam covers quite a bit of material. It seems like we've been on this forever, right? The reason is it's all about equilibrium from the start. So units 14, 15, and 16, they're really all about equilibrium. Now, a big chunk of that had to do with acids and bases, of course, but it really is all around the core of equilibrium. So what I'd like to make sure that we get is, get some of the important concepts here. Let's start out by just talking about equilibrium. What are some of the things that you need to know? First of all, what is equilibrium? How do I say that a system has reached equilibrium? What do I say about the rates of the forward versus the reverse reactions? All right. Uh, how do I calculate the equilibrium constant? And what does the value of the constant tell me about the position of equilibrium? Remember, the equilibrium constant is a ratio. So does it tell me that the equilibrium favors products or that it favors reactants? Or maybe it's right in the middle. We also talked about what happens if how do I know if a system is in equilibrium or not? Remember, we have the reaction quotient, QC, which has the same formula as the equilibrium constant, but we just have to use it to compare and see if it is smaller, equal to, or larger than the equilibrium constant. And that'll tell us not only whether the system is in equilibrium or not, but which way it's going to go in order to arrive at equilibrium. We said that a lot of times we work with gases, and rather than measure concentrations, we measure pressures. So you should be able to do conversions between Kc and Kp. And many times the questions have to do with, okay, if a system is at this concentrations and we let it go to equilibrium, what is going to be the concentration of this particular component if the equilibrium constant is this, and whatever, right? By the way, I think I mentioned earlier that I was going to give you a handout and I couldn't find it at the time. I think I finally found it. Here it is. So this is the file that I sent you earlier. And this is what I'm going to give you on Thursday. And here between you and me, honestly, if you guys want more stuff in here, that's fine. Just let me know and I'll put more stuff in here. So the first thing you have is a table of, periodic table, which you might need to do calculations of molar masses or something like that. I also have here some formulas. Here's the conversion between Kp and Kc, how to change Celsius to Kelvin, the value of Kw, how do you get Ka and Kb from Kw, pH, pOH, the Henderson-Hasselbalch equation. I even put in here the quadratic formula. You don't even have to memorize that one. You just have to apply it if you need to, right? And then I also put a few charts in here that I thought would be useful. Uh, so you don't have to write these things and waste space on a cheat sheet or notes card. So remember the Le Chatelier principle. These are some of the changes, and do they shift equilibrium or not? And do they change the equilibrium constant? So it's kind of like a quick look that you can have in there to see. It doesn't tell you exactly which way things go, but you should be able to use that table to, whatever you need for it. I also gave you here the acid-base properties of salt solutions. So just to remind you of what are the different scenarios we talked about. All right. So you have to memorize that. And here's a solubility table. Again, if you have a question where you're asked, will there be a precipitate, but they don't tell you which one specifically, you may have to look up kind of the exercise we did today at the beginning of class and figure out, well, what is the possible precipitate that could form? Okay, so that's the handout that I have right now, and I've sent it to you in an announcement. But if you guys feel like you'd like to have more stuff in there, that'd be cool. Remember, yeah, you do have to memorize how to assemble the formula for an equilibrium constant, whether it's Kp or Ka or Kb or Ksp. You have to be able to assemble that, okay? Uh, Now, if you have anything else, you also were supposed to memorize the identities of the 7 strong acids, all right? So I was tempted to put it in there, but I figured, no, you guys should memorize that. Um, let's see, let's go ahead with the review. And at the end, let's talk about the idea of, originally, if you had taken this exam in the classroom, you would have been allowed a 6x4, cheat sheet or note card. And I don't see the point in it right now, but we can discuss it if you want after we finish the review, okay? So let's hold that thought for now, please. Okay, again, going back to the principles, all right? These are some of the principles. The Le Chatelier principle is crucial. I need you to understand how it works, all right? And how to implement it or apply it when you have a system and you make changes in some of the conditions, okay? That table on the handout helps you kind of summarize things, but you still should be able to explain or to choose a proper explanation for the outcome of an equilibrium system that's subject to some kind of a stress. Okay, so let's see what else is important for this test. Acids and bases. Oh my gosh, we did a lot of this stuff, didn't we? So here are the basic skills. Number one, if you see an acid-base reaction, you darn got to recognize who is the acid and who is the base, okay? This is a crucial skill at any level of chemistry in college, okay? When you have a reversible equilibrium, like a reversible ionization, you need to identify which components make, excuse me, which components make up the acid-base conjugate pair. All right, you had to recognize strong acids. We only made you memorize 7. There's not more than that, but we only made you memorize 7. So if you see the formula HNO3, you know, hey, that's nitric acid. That's a strong acid. All right. Now, you also have to be able to calculate pH if you're given the concentrations of either hydrogen or hydroxide ions, or vice versa. If you are given the pH, you need to be able to calculate those concentrations. Also, If you have a strong acid or base and they give you the molarity, remember they ionize completely, so you have to be able to calculate the pH of a solution of a strong acid or a strong base. All right. Now, here come the variations on this topic, right? What is the equation for the ionization of a weak acid or base in water? Don't forget, these guys are weak acids, weak bases. They still produce the corresponding hydrogen or hydroxide ions in water, but there's a big difference in the way you write that equation, right? That's right, it's a double arrow, all right? Reaction of a weak acid with a strong base, reaction of a weak base with a strong acid. Again, it's just a matter of identifying who is the acid and who is the base. And in the case of weak acid and base, even if you've never seen that formula before, you should be able to construct what is the formula of the conjugate. In other words, the product of that reaction, all right? How to tell if an acid or base is strong or weak. There are several criteria, and I have a practice slide later on where we're gonna list out the characteristics of a weak acid. How do I tell that an acid is weak? There's several criteria, okay? We'll do that later on. And again, how do I use Ka and Kb information? In many of these problems, what you do is you're given, let's say, the molarity of a weak acid with the value of Ka, and you are asked to calculate the pH of the solution, for example, things like that. So here are some of the calculations that you do with pH and ice tables. There are three parameters typically, the molarity, the Ka, or the pH. So you could be given the molarity and the Ka, and you have to calculate the pH. Or you might be given the molarity and the pH and asked to calculate the Ka, right? So these are some of the types of questions that we've dealt with in class. Same thing with bases, right? Just remember that in a base, the pH has to be converted to POH, or alternatively, the concentration of hydroxide ions has to be converted to the concentration of hydrogen ions, or alternatively, you had to calculate POH and convert it to pH, right? Don't forget salt solutions. Whenever your salt contains an ion, whether it's the cation or the anion, right? And they represent conjugates of a weak acid or base, they're going to hydrolyze. And again, you use ice tables to calculate what would be the pH of the resulting solution, all right? And qualitatively, just inspecting a solution of a given salt, will it be neutral, acidic, or basic? I gave you that table in the handout. So it's just a matter of looking at the formulas and going back to that table and identifying, okay, what is the category that this base, this salt falls under, all right? Okay, so I'm going fast with this because I'm just giving you the principles that I want you guys to have, a fairly solid understanding of, so that when you study back and you decide to find practice problems, these are the kinds of things you should be practicing, all right? Okay, uh, we have done titrations, right? Now, because we did not do the pH titrations in lab, and because we just did the exercise, you know what? I am not going to ask you quantitative questions about titrations. Now, you have to be able to do a titration with an indicator, finding an endpoint, because that is, standard skills for any chemistry student to find the concentration of an unknown. As a matter of fact, and think in this exercise you did this past week for finding the KSP of the potassium hydrogen tartrate, you had to analyze titration data. And some of you guys were a little confused. You kind of forgot how it works. So again, that was a good practice there. Here's what's important for me. If you are doing a pH meter titration, from the equivalence point, specifically the pH at the equivalence point, how do I tell that the acid or base being titrated is weak. Remember that? Okay, so make sure you remember that for a weak acid or base, the equivalence point is not going to be at pH 7. It's going to be either higher or lower, depending on whether it's a base or an acid. All right? Okay, what else? More titrations. What happens when I titrate a weak acid with a strong base? Remember that graph? We just did it in the exercise on last week, right? So you have a pH versus volume. There's a bump, right, in the first part because that's where the acid and its conjugate base are exercising some buffering activity. You had to consider that once the acid is completely neutralized, the conjugate base will hydrolyze, and therefore the equivalence point occurs at a pH higher than 7. Remember that? All right. Now, we didn't get to do any quantitative exercises, so I will not ask you a quantitative question in the test. However, you had to remember that if I am titrating a weak base with a strong acid, the curve is reversed, right? You start at a high pH because you start with a base, and as you neutralize it, you go towards a lower pH. Again, you're going to have an S-shaped curve where the conjugate acid that's produced by neutralization of the base is now going to hydrolyze and give you a solution that has a pH lower than 7. Okay, just remember those features. I don't need you to remember all of the quantitative analysis, all right? Mainly the features of this type of process. Okay, Henderson-Hasselbalch. Okay, I'm giving you that equation in your handout. So you don't have to memorize it, okay? It's going to be in there. My main concern is that you know how to use it, right? First of all, what makes up a buffer solution? How does it work? Okay, you have to have a weak acid and its conjugate base. So if I give you pairs of formulas, you have to be able to tell if that pair is a conjugate pair and therefore will it make a buffer solution. Also remember that the ability or the capacity of a buffer to work depends on how much of that acid and base you have in there. And so, the higher the concentrations, the more effective the buffer is going to be at neutralizing any, attacking any invading acid or base. And also the other thing is that when you build a buffer, you want to choose a system that has a pK close to the desired pH. That way you don't have to manipulate the acid and base ratio to be kind of like very disproportionate. All right, so don't forget those kind of qualities there. And of course, you have to be able to do calculations. Like if I give you a concentrations of this and this much base, this much acid, what's going to be the pH of the solution? Or if I tell you I want to make a buffer with this target pH, what should be the base to acid ratio? Things like that. Those are calculations you should be able to do. All right. Uh, we discussed 4 ways of obtaining the Ka of a weak acid. These are Ka adventures, right? Sorry about that. Couldn't resist the pun. So the standard way we did, and this one we did in class, but we also did it in our exercise that we did in lab last week. You take a weak acid solution of known concentration, and from the pH and an ice table, you can find the Ka. You can also have a solution of the conjugate base, in other words, the salt, and from there, you can calculate the hydroxide ion concentration from where you get the Kb, from where you can calculate Ka. We also said that a buffer solution that has equimolar concentrations of the weak acid to base, the ratio there, what that does basically is, according to the Henderson-Hasselbalch equation, if the base to acid ratio is 1, that means that that log of base over acid equals 0, and therefore the pH is the pK, and you can get the Ka from there. The fourth method was the one where we looked at the titration curve, but since we're not going to be doing any quantitative type of questions, I kind of scratched that out. So just know that you can do it this way, but I'm not going to ask anything like that in the test, okay? Okay. The last set of topics we discussed were solubility equilibria, right? So we have an ionic compound and it can barely dissolve to produce particular ratios of the corresponding ions, right? and the KSP will be the product of the molarities of those ions. Now you have to remember to elevate them to whatever exponent corresponds to their stoichiometric ratios. This sounds like a complicated formula here, but I think it should work. The M's and the N's, they kind of should work. So hopefully it's all good. Um, hey, you don't need to be able to find values of KSP. In the old days, we would have given you a table of KSP values and you would have had to use it. But what we do nowadays is in any question where you need the value of KSP, uh, you're going to be given that value. So there might be some questions where they give you the KSP and you have to calculate the solubility either in grams per liter or moles per liter, or vice versa. They might give you the solubility and you have to kind of like build your little ice table to find KSP. All right. In all of those type of questions, remember, don't forget, all right, that when you have a ionic compound that dissociates such that the stoichiometric coefficients are not 1, all right? I want to, oops, sorry, I kind of messed up here. I can't seem to be able to get my highlighter to work, but anyway. So be aware of that, okay? You have to be careful. Like for example, we did an exercise a little while ago with zinc hydroxide. And we had to remember that the hydroxide, there's 2 units of hydroxide for every zinc. And so when you calculate KSP is molarity of zinc times molarity of hydroxide squared, okay? Don't forget that. Also, don't forget that when you do the solubility equilibria, the ice table, if an compound has S solubility, remember that in the case of zinc hydroxide, you would have S moles per liter of zinc, but you would have 2S moles per liter of the hydroxide ion. And again, I'm referring to the exercise we just did in our class today with the precipitation of zinc hydroxide. Okay, applications. Okay, there's several things we have to be able to do with solubility equilibrium. Number one, if I give you the concentrations of the ions, you have to be able to use the ion product Q to predict if the precipitation will occur. Remember, the ion product Q is the same as the reaction quotient that we did in the beginning, where you compare it with the actual equilibrium constant and ask, is it less, is it the same, or is it more than the equilibrium constant? You should be able, if you're given the KSP of several possible compounds, and then you're asked, okay, I have a mixture of these compounds at these molarities, and I'm going to start adding a precipitating agent. Which one is going to precipitate first? Okay, so fractional precipitation, you remember that. Also, the common ion effect. We said that a solution that I'm sorry, a saturated solution of an ionic compound, if you add some more of the ions, right, on the right side of that equilibrium, by Le Chatelier, it's going to drive the equilibrium back towards the insoluble compound. So we can selectively decrease. So for example, let's say I have a mixture of ions of, let's say, silver chloride and, no, sorry, silver chloride and silver bromide, for example. So if I add bromide ions to that solution, I am going to cause the silver bromide to precipitate. So even though it has a KSP that's smaller, I'm going to selectively cause it to precipitate. So these are some of the things that you can do. Also, we know that particularly for compounds that have ions that are susceptible to pH, like hydroxides, carbonates, the various phosphate derivatives, things like that, you can use pH changes to increase the solubility, right? And we talked about, cleaning up different kinds of deposits of either hard water or, for example, acids or stuff like that. And the topic we talked about today, the effect of a complex ion on solubility. Again, I don't need you to know the quantitative aspects. Technically, you should be able to look at 2 equilibrium systems, one with KSP, one with KF, and calculate which one's going to win out quantitatively. Now, I'm not going to do that. The most you need to know is if I give you a table of formation constants and possible complex ions, you can ask whether a given compound will be soluble or not. Okay, so that's pretty much the principles that I want you to kind of like have a handle on. I've probably missed a few here, but you do have your study guide that I posted, last week. So you can go back to that. If I missed anything and you're not sure, just ask me, guys. Okay, just ask me. Okay. The rest of this is a series of practice exercises that I have in here. Okay. So let me just pause here for a moment. All right. And let me see if there are any specific questions. I know some of you guys have some things about the exam itself or things like that. So let me know if you have any specific questions. You can raise your hand, you can unmute your microphone, you can put a message here on the chat. Oh, before we go there, two things I need your feedback on. Number one, um, if you don't mind, please think about for you on your schedule what would be a convenient time or something that works in terms of me being available for like an office hour. Right now, I'm thinking I can do one at 10:30 in the morning on Thursday and another one at 2:30. All right, 10:30 in the morning and 2:30. So two sessions essentially. Uh, Sorry, only 1 hour. And what I would do is I would give you the link to join that Zoom session. And again, you just come in just like you did today, and I'll let you in, and you can ask me questions in there. Okay. You don't have to make appointments. Don't worry. But I might actually just let one person at a time, just so we have a little bit of an opportunity to talk privately, especially if you want to talk about something a little more private. Okay. So so again, so right now, Thursday at 10:30 in the morning, and another session at 2:30 in the morning. I'm sorry, 2:30 in the afternoon. Okay. So that's it. So think about it a little bit, and if you have any strong feedback to the contrary, just let me know. Okay, just be honest. Okay, just be sincere. You can even, if you want, you can chat. Send me a chat post privately. You don't have to put it to everyone here. If you feel like you want to maintain your anonymity. Okay, all right. The other question that I had here for you was, okay, if you had taken this test in a real classroom setting, you would have been allowed a note card. Right now, the way it's set up is you are not allowed to have any other materials. Uh, but look, guys, I don't want to make this difficult for you. I want you guys to just kind of minimize the stress you probably already have, right? And be able to focus on just answering the questions on the test. Again, from my perspective, it's not that hard. But again, everybody has different opinions of what a hard test is and not. So let me tell you this. Here's what I think. If you want to bring a note card, a cheat sheet during the exam, remember, I'm not going to be watching you, so I don't even know what you're doing. Like I said, you are expected to sign off on the academic integrity policy, which means that you are going to commit yourself. You're not going to be browsing the internet looking for answers. You're not going to be calling, your former, SI leader or one of your classmates to ask for, what did you answer here? What did you answer there? Okay. Look, guys, I'm not going to go there and try to, police that. Okay. I'm going to put my trust in you. I know that you guys are going to do your best. Now, if you want to bring a cheat sheet, here's what I would say is I need you to upload it together with your calculations pages. So there's about, right now, the way I'm thinking, the exam's going to have about uh, 20, let's see, 26 questions. The first 20 are all multiple choice. You don't have to submit any calculations. The other 6 questions, they're going to require you to write on a piece of paper, or alternatively, if you have an iPad, you can just Notability your thing there in there. And you'll have to submit those as an upload. How about this? if you guys want to have a cheat sheet, please keep it to a 6x4 size. And I'm going to ask you to also submit that along with your calculation sheets. What do you guys think of that? Crickets, crickets. Oh, thank you. Somebody says sounds good to me. Okay. Do you guys think that's fair? I think that's fair. I mean, like I said, I'm trying to abide with the school policy and all this stuff. Okay, I'm trying to do that, and you got to understand that I do have a responsibility to hold to the rules, that the department has set. Uh, but I know that originally you were promised that you could have a cheat sheet, and probably some of you have already done it. Excuse me, choking on my own saliva here. Sorry about that. Okay, so how about that? What do you guys think? Good. Okay, so we'll do that. Okay, I'm gonna pause the recording here. And I'm going to show you the rest of the slides in here. And then if you want to stick around, we can stick around for another hour. And I can help you with some of these questions if you want to kind of tackle them throughout, okay? So let me show you very quickly. I'm just going to go through these questions. Now, you have this PowerPoint available to you, so you can just browse through it yourselves, okay? So the first question, I'm sorry, I'm choking here. First question is, here are 5 reactions. It gives you the equilibrium constant. Can you arrange them in order of increasing tendency? So increasing means from low to high tendency, right? So it's a matter of asking yourself, what are the relative values of these things? So, if you guys want to work on that, you can work on that. Here's another question. This is more a quantitative one. I have an equilibrium system. I put 2 moles of PCl5, and then at equilibrium, I found 0.4 moles of chlorine. What is the equilibrium constant? So you have to set up an ice table, and based on the amount of chlorine available, you have, to kind of calculate what are the concentrations of the remaining species in here, all right? And therefore calculate Kc, all right? So that's what the question is about. Okay, how do we tell if an acid is a weak acid? Hey, why don't we do that? Let's do that one together because I think that's an important question. So let's do that one. I'm going to come back here to our screen here. I'm going to take us to this video here. Okay, everybody see that there? All right, here we go. So, I guess I'm still recording here. Okay, we'll leave it in here. How do we tell if an acid is a weak acid? In other words, what are some of the characteristics of a weak acid? Remember, some of these have to do with a observation you make chemically, but it might also have to do with something you see in writing. Something is written down. You say, oh, that must be a weak acid. Okay. Anybody want to give it a try? What are some characteristics?
Well, Professor, the way I remember is that a strong acid will dissolve completely or react completely. So I know that a weak acid will not result.
Very good. That's one. That's a good one.
That's how I remember it.
In other words, we could say that it doesn't ionize completely. Very good. So whereas HCl will completely dissociate into hydrogen and chloride ions, HF doesn't. Now, if I show you the ionization equation for that process, what do I notice in a weak acid versus a strong acid? What does the ionization equation look like? There you go. So Shefali, very good. Double arrow, very good. That's right. In other words, the ionization equation is reversible, right? In other words, when you show it for HX, it'll look like this. It'll have a double arrow as it goes into the component ions. Okay, very good. Okay, anybody else can think of anything else? Very good. Very good, Jay. Ka is going to have a small value, right? You know, they're all small. You know what I'm saying is you don't write Kas for strong acids, but if you did, it would have a huge number. It would be close to, you know, like 100, you know, 100 million, whatever. But the Ka for a weak acid would be a small value. All right. Can anybody think of anything else?
It has a large value for pKa.
Okay, so this translates into a pKa. That's going to be kind of like, maybe, let's say not large, but let's say that it is, you know, higher than usual. Since this is so small, it'll be higher than usual. All right. What about when you calculate pH? With a strong acid, we just look at the initial concentration of the acid and we say, oh, so let's say nitric acid, if it's 0.1 molar, then what would be the hydrogen ion concentration? 0.1 molar, right? But in a weak acid, what happens?
You would have put like plus y, and then you would have to calculate y in your ice table.
Right, because this concentration is not going to be equal to the initial concentration. Remember, in a strong acid, whatever I start with, it's all going to dissociate. And so that's going to be the same molarity for hydrogen ions. But in the case of a weak acid, because it doesn't ionize completely, your molarity is not going to be there. Oh, somebody mentioned here, oh, Jackie, a weak electrolyte. Very good. Weak acids are also weak electrolytes. They do not completely ionize, and therefore you don't get a full conductivity in water. All right. That's a pretty good assembly of things, right? Don't you think? That's a good one. Another one you can think of is the pH at the equivalence point. Of a titration is what?
7.
It's going to be higher than 7, right? It's going to be basic. So when I titrate any HCl with NaOH, of course, everything gets neutralized. You end up with water and salt, and it's pH 7. But with a weak acid, your product of neutralization is a weak base, which then hydrolyzes and gives you some extra hydroxide ions. So I think that's a good little exercise, I think, for us. It's a good way to think. So some ways that you can tell that an acid is precursor. There's a few more, but you can think about it later on, okay? All right, let's come back here to our questions here that we had. Let's see what else we have here. Let's see, I have, oh, here's an interesting question. Here's an equilibrium. They give you the Ka ones, and it asks you, which direction is this equilibrium going to be? Is it going to be lying to the left, to the right, or in the middle? Or otherwise, you know, another way of saying it, does it favor reactants? Does it favor products? Or is it in the middle? Okay, that's another question I have in there. Hard water deposits, which are calcium carbonate, have built up around your bathroom sink. Which one of these substances would be most effective in dissolving the deposits? Ammonia, bleach, lye, or vinegar? You have to think a little bit about that one, but I did give you the names of the compounds. So you may have to look them up and see if those guys would work, okay? All right, I'll let you think about that. Oh, here's a numeric problem. Oh, this is a big one, okay? Again, like I said, I'm just going through them. This is where they give you a certain amount of a substance. Hey, good old caffeine. Hey, some of us could use some of that right now. Anyway, what is the pH of the solution resulting from dissolving 2 of these tablets in a 225 milliliters of water? And there's the KB. So this is a pretty involved exercise. You guys might want to work on it. In the bottom of the slide, if you open the actual file, not the slideshow, but the file, you'll be able to see the actual answer to the question, right? pH of a buffer solution that contains, 0.25 molar benzoic and 0.15 molar benzoate. And there's the Ka for benzoic acid. Question 8, you know what? Don't do this one. This is pretty much the problem we did last week in our, extra lab session. It's kind of like building a buffer where you don't have the actual components. You have acetate and you have HCl. It's just slightly different than the one we did last week, but we already did this, so don't bother with this one, okay? Don't bother with this problem. Here's the solubility one. What is the silver ion concentration in a saturated solution of silver sulfate? So that means you had to find out what is the formula for silver sulfate, so you can build the, the proper equation that corresponds to KSP. Be careful with the charges and the stoichiometric coefficients, and therefore the exponents on the expression of the equation, of the KSP. And I think this is the last one that I have. Concentration of magnesium ions in seawater is 5 times 10 to the negative 2. What hydroxide concentration is needed to remove 90% of the magnesium by precipitation? So remember, what you're going to do here is you start with that molarity, find out what would 90% of that be, and knowing the KSP, calculate what would be the required concentration of hydroxide ions to form a saturated solution with that amount of magnesium ions. All right. So there we go. And that's the questions that I have in there. So what I'm going to do now is I'm actually going to stop the recording here. And you can combine this talk that I had here with the PowerPoint if you want. All right. And we can join later, okay? So I'm gonna stick around for a few more minutes till about 8 o'clock. If you guys wanna work on those problems, go ahead and do that. And I'll be here to answer your questions. Let me just pause the recording here.